Hello and welcome to the 2-minute talk on the Higgs boson. Now, in order to understand the Higgs boson, we have to understand the four forces that go around the universe. The electromagnetic force is the strongest one and deals with light. The strong force deals with attaching particles, electrons and quarks and stuff together. Weak force deals with radioactivity, and gravity, the weakest of the force, deals with falling apples and what you have. Now, Einstein came up with general relativity, which basically explains that objects warp space-time around it, like a fat man jumping into a pool, for example. But what happens when two of these objects collide together? Apart from crashing into each other, obviously. Well, the electrons have to detect this and notify the other planet and space-time to sort it out. And the way they do this is sending things called photons, like a little postman. So, other people wanted to dismiss this theory, and one guy came up with the idea of combining the electromagnetic force with the weak force to create the electromagnetic weak force, or electroweak force. But they needed new evidence for this, so that means that there is no weight and that objects float along the Higgs field. Some float on the top, others sink to the bottom. And the people and the messengers which come to there are the Higgs bosons. Now, at CERN this year, scientists have found evidence for the Higgs boson using the Large Hadron Collider to collide particles together to create the decay here and here to show that the Higgs boson does exist. And that theory is proven now. But some other people are coming up with new ideas, such as looking into strong force and discovering string theory, which means the entire universe is basically made out of strings. But they need new theories like supersymmetry and multiple dimensions. But Higgs boson remains the best example of science in the universe. So thanks for watching, and this has been 2 minutes.